related, but they really are. Distance, point, and circles. Now, I know you've been taught the distance formula, but have you ever been shown where it comes from? So let's talk about the distance between 2 points. Let's say I have a graph, and I have a point here and a point here. And let's say this point is the point x1, y1, and this is the point x2, y2. And we're trying to find the distance between the 2 points. So the distance straight between the 2 points. Let's call that D for distance. Is draw a right triangle. How can I find that distance? Well, what we can is the Pythagorean theorem. Let's see if we could figure out those legs of that right triangle. Well, this leg would be the differences in my x's, so the change in my x's. And this distance is a vertical distance. That's going to be the change in my y's. So thinking about Pythagorean theorem, it's leg squared plus leg squared equals hypotenuse squared. So leg squared plus leg squared equals hypotenuse squared. Find the change in my x's. That's just x2 minus x1. The change in my y's, well, that's just the difference in my y's. Just Pythagorean theorem. That's all that we just wrote down. The only what you see on formula charts is that to get D by itself, we'd have to take the square root. So that would be the square root of x2 minus x1 squared plus y2 minus y1 squared. Now, technically, we should have a plus or minus, but in the distance formula, they don't put that there because they always want the positive square root because we're talking about distance. Let's practice. Let's say we're finding the distance between -1, 4, and 3, -2. My points would be x1, y1, x2, y2. So using the distance formula, we would have the square root of x2 minus x1, so 3 minus a -1 squared, plus y2 minus y1, so -2 minus 4 squared. Now be careful here. Some people think, well, since this is a square root and these are squared, that I could just remove those. So here's a warning here, just to make sure we know about order of operations. If I had the square root of 3 squared plus 4 squared, okay, some people, they can just, square root of squared, this would just be 3 plus 4, which is 7. If order of operations, it says to do everything inside first. So 3 squared is 9, 4 squared is 16, the square root of 25. That is not 7. must follow your order of operations. So order of operations, parentheses, so we're going to start inside those parentheses. 3 minus negative 1 would be 4, so we're still under the square root here. So 4 squared plus negative 6 squared. 4 squared is 16. Plus negative 6 squared is positive 36. So every time you square a negative, it's going to be positive. If you're putting it in the calculator, make sure you put parentheses. That's the square root of 52. And we can simplify that. That's 4 times 13. So that's the square root of 4 times the square root of 13, or 2 square root of 13. Talk about midpoint. Let's try to find the midpoint between 2 points. I'll just use the same 2 points. Back on this graph. The midpoint. Would the midpoint be closer to this point or this point? Or would it be right smack in the very, very, very middle? If it's in the very, very middle, then it's halfway between the x's and halfway between the y's. So all you're actually doing to find midpoints is averaging the points. Average the x's and the y's. So to find halfway between them, we would add them together and divide by 2. Add the y's together and divide by 2. You're just averaging your x's and averaging your y's. So in our example, we had negative 1 and 3, and then 4 and negative 2. The average of negative 1 and 3, that'd be negative 1 plus 3 is 2, divided by 2, that's going to be 1. 4 plus negative 2 is 2. 2 divided by 2 is 1. Now I invite you to try finding, so let's say we have the points 1, negative 6, and negative 8, negative 4. And pause and see if you can find the distance and the midpoint. Pause the video. I'll show the answer in just a second, but I want you to pause the video. Seven halves and negative 5. Are circles. So let's think about a circle. Okay, so if I have, we have a center, oh, it doesn't matter where I'm at, so I'll just draw it here. But some center here, HK. So I call the center HK. In a circle, the distance from there to any point, so let's call any point on it XY. The distance from here to here is called the radius. So the radius is being represented with an R. Finding that distance R, I could turn this into a right triangle. Change in X, change in Y. We're basically using our distance, our Pythagorean theorem again. So change in X squared plus change in Y squared equals R squared. Well, in our case, the difference in the X's is X minus H. The difference in the y's is y minus k, and the radius is r squared. This is the equation of a circle. I had the center is 0, 3, and the radius is 2. Well, in this equation, the center going in as h and k, and the radius is r. So x minus h, so x minus 0 squared, then y minus k squared equals the radius squared. I can clean that up a little bit. That's just x squared, and that's 4. What about, let's see, a center of how would I find the equation here? The same. H, this is k, this is the radius. So x plus 2 squared plus y minus 1 squared. So I put a plus 2 because it was minus an h, so minus negative 2. And that would be 7 squared, 49. What if I give you the equation? Could you tell me what the center and the radius are? Minus h, y minus k, so that means the center has to be at 3 and a negative 4, y minus k, and the radius would be 3. Another one. Center would be negative 3, and the radius would be 6. Now the last example we're going to do, we're given the equation, but somebody distributed everything out. Oh, no. So I need to figure minus something squared and y plus or minus something squared. So the first thing I'm going to do is match things up. So I'm going to have x squared and a 4x together, and then y squared minus 6y together. And I'm just going to move that 23 to the other side. Now remember, I'm trying to get something squared plus something squared equals a number. Looks a lot like completing the square. I'm trying to figure out what's missing here and what's missing here. Whatever is missing is going to get added, and so it's going to get added here as well. Square plus 4x. Well, I start thinking to myself, I think this is going to be an x, and then half of that, it's going to be an x plus 2. Distributed out x plus 2 times x plus 2, I would have a 4 here. So I need to add a 4 there and on the other side. Now it's going to be a y. I'm trying to figure out to be y minus half of 6 would be 3. Well, that would only be true if this was a plus 9. 3 plus, so that'd be a 13. That would be a 36 there. What does that give me? That gives me a center of -2, 3. So that was that same equation all distributed out, and a radius of 6. Now, what if I also ask you to graph it? Center, -2, 1, 2, 3. Here's the center. How would I graph a circle? Well, the radius is telling me how far out I have to go. So I know I'd have to go that far out, right and left. So 1, 2, 3, 4, 5, 6. I know I'm going to have a point here. 1, 2, 3, 4, 5, 6. Another one here. I have to go up 6. 1, 2, 3, 4, 5, 6. And down 6. 1, 2, 3, 4, 5, 6. And that gives me my circle. Mine's a lovely circle, by the way. Well, we have here, what's the domain of this circle? Well, it's going from here to here. So that point is at 1, 2, 3, 4, 5, 6, 7, 8. That's starting at -8. And then 1, 2, 3, 4. So -8 to 4, and those did have points, so they were included. The range is going from down here to up here. Down here is at a -3, and up there is at 1, 2, 3, 4, 5, 6, 7, 8, 9. Those are both included.